Okay, hello. So this lesson is going to be around what we're going to call about radicals and square roots, and then ultimately irrational numbers. So what I want you to think about is when we talk about square numbers. So if we have what is 2 squared, right? And we know 2 is our base number, and then we have this little 2 to the which is our exponent. Then what we do is we do 2 times, which is 2 times 2, so it replicates itself twice, and so that this 2 squared is 4, right? So we know that 2 times 2 is 4. So 2 squared is 4. I think we understand that concept pretty well. If we had an exponent of 3 to the third power or 3 cubed, yeah, we would say 3 times 3 times 3, which equals 3 times 3, which is 9, times another 3, which is 27, equals 27. And so that would be 3 to the third power, all right? Or 3 cubed instead of 3 squared, which would be 3 to the second power. 3 squared would be 3 times 3, which equals 9. And what we need to see is that this is our sort of base number that we start with, and then we are either, in this case, cubing it, placing it to the third power, or in this, our base number, and it gets squared, okay? So when we talk about finding the square root of a number, just going to erase that for a second. We talk about finding the square root of a number. We use this symbol here. And that symbol, it almost looks like a dividing sign, but it's not. It's not a divisor. It's not the divisor sign. What this is called a radical, the radical sign. And that radical symbol usually houses a number, say 9. And what it's asking is, what is the square root of 9? As in, what number times itself gives you 9, right? And there's this idea that we're looking at for the square root. We're looking for, if I put it here in this little here, I'm going to put a little 2. We're looking for 2 numbers that are identical, or twins, that multiply together become 9. So the square root of 9 equals just one of them, 3. And if you think backwards, it's like this. 3 squared equals 9, right? So the square root of 9 is that 3, yes. But when we see them in as a radical in this form here, this number right there, the index isn't always used. And if there's no index, then we know we're talking about squares. We're talking about 2 numbers, and there's no index there. Later on, there can be an index, because then it means more. It could mean, in the case of if it was asking what is the square root of 27, and then gave us this, oh, not the square root. Now we're looking for the cube root. The index here gives us 3. And we know we're looking for a number that times itself 3 times is the root. So in this case, 3 times 3 times 3 equals, 27. So this cube root of 27 is 3. Okay. So I'm jumped ahead a little bit with the index, but I just want to let you know that we're going there. And you'll see that in your homework. Let's start back. So here, if I'm asking, what is the square root of 16? We're going, what number? The square root, I'm going to give it an equals. Square root of 16 equals what? What number times itself gives you 16. So it's two identical numbers, right? So hopefully you already can see it. 4 times 4 equals 16. These are perfect. This is a perfect square. Comes out perfectly. My answer is 4. 4 is the root that got squared. Yeah, so I'm looking for the square root. Yeah, and the root that was squared was 4. See that? I'll try another one. What is the square root of 81? So again, asking ourselves, what number times itself, I'll give it a little dots because we use algebra, so times itself gives me 81. Hopefully you know your squares and we'll say, oh, well 9 times 9 is 81 and therefore the square root is 9. The root that was squared to get 81 is 9. Another one. These are all perfect squares and making us very easy for us. They'll get complex along the way, but just not this week, all right? So, yeah, square root of 36. What number times itself will give me 36? Hopefully you can see it as 6 times 6 equals 36. So therefore, the root, the number that got squared, the square root is 6. And there's my answer. So that's how you find those square roots. But like I said, sometimes it's not just a square. So if there is no index number here, then they're asking for the square. They're asking for those twins, those two identical numbers, the square root. But if there's an index number, then they're asking for something else. So in the case of if there's a 3, they're asking for triplets. They're asking for 3 identical numbers that are the root. So if I have 8 here, what number is the cube root here? What number times itself 3 times will give me 8? Well, hopefully you know it and can see it. It might take a minute to think about, but it's 2. 2 times 2 is 4, times 2 is 8. Because think about this, 2 to the third power equals 8, which is ultimately what it's doing. What number, yeah, times itself 3 times gives me 8. And so therefore, my answer for the cube root of 8 equals 2. Cube roots, we can go even higher. We can do bigger numbers. I don't think that we get too crazy in your homework, so I think we just do squares and cubes. Let's think of another one. How about this one? The cube root of, I'll erase that, of 125. Oof. What number times itself 3 times? Times itself 3 times. Yeah, will give me 125. Hopefully you've thought of it already, and I'll give you a hint. It would be 5 times 5 is 25, times another 5 is 125. So in this case, my cube root will be 5. See that? So you can look at some of those and then see if you can find the cube roots for those. Okay, so that's the squares and cube roots. Now we're going to get into an area that's a little different, and it has to do with rational and irrational numbers. So when it comes to looking at a rational number, let me try, I'm going to change this to a different color. But rational numbers have the word, you're looking for a rational number, has the word ratio in it, right? Rational has the word ratio in it. And a rational number is any number that I can express as maybe 3 over 2, or could be 1/2, could be 8 over 1. 8 over 1 could be a whole number, could be a fraction like this, and they often are numbers that, rational numbers are numbers that terminate. So even if I have like 1/3, it will be 0.3 repeating, right? You've got that idea, it's 0.3 repeating, and in that repeating bit is kind of, it terminates into that it repeats. So, or if I have 1/4, it'll be 0.25, right? So it terminates in that 5, it stops. It doesn't go on and on and on and keep changing numbers. But we have numbers that do that. We have numbers that will go on and be like 3.1468. I'm not even doing it right, but 3.149, I think it's 9, and goes on and on and on and on and keeps changing numbers, right? This is actually pi, is our pi, and pi does this. Pi is a number that keeps changing and going on and on and on and never terminates, and never kind of starts to repeat itself, like as in 1/3 does. So pi is what we call an irrational number. An irrational number. They're more tricky. So an irrational number, yeah, will keep going and not terminate, changes, and they're very hot. So often though, with our square, if we're looking at our square roots of numbers, we do have lots of irrational numbers. They're often seen as square roots. Not in our perfect squares, and but some of them are, right? So now let's look at, if we know that the square root of 4 is 2, right? And we know that the next big square root, I'm going to put it over here, the square root, which is the next perfect square, will give me 3. Well, that'll be 9, right? I want you to imagine that there's a number line here. So we have 1 over here, 1, and here's 2, and here's 3, and we're going on, right? And here's our square roots, right? So the square root of 4 is 2, the square root of 9 is 3. What about between the square root of 4 and the square root of 9? Well, there's a lot of square roots here, but they are not perfect squares. So they end up being decimal numbers, and in some cases they become irrational numbers. So if we look at it, so the square root of 4, then there's the square root of 5, then there's the square root of 6, then there's the square root of 7, I'm running out of room, and then there's the square root of 8 between them. See that? 5, 6, 7, 8. So square root of 5, square root of 6, square root of 7, square root of 8. And they do actually end up on our number line between here, just like this. And you can imagine. So that you can see that 5 is closer to 2, is between the square root of 5. The answer is going to be 2 point something, and it's going to be closer to the whole number 2 than 3, but between 2 and 3. If I look at the square root here of 8, the square root of 8, the answer is going to be 2 point something, but it's going to be closer to 3. That answer is going to be closer to 3 than it is to 2, but it's definitely going to be between 2 and 3. You see that? So your homework is going to ask you something like, it'll go, what about the square root of 15? What's it closest to? And what numbers, whole numbers, is it between? And which is it closest to? So hopefully you can, if you know your squares, you know the next one to the square root of 15 is the square root of 16, which is 4, because 4 times 4 is 16. Yeah, you see that? And then over here, 3 will be the square root of 9. Yeah? And so therefore, 15 lies between 3 and 4, but closer to 4. It'll be closer to 4 on the number line. And if I use a calculator to find the square root of 15, it's definitely going to give me 3 point something something, maybe 8 something, or 9 something, so that it's closer to 4 than it is to 3. Okay, so hopefully you can follow that example and play with this to kind of get close, see where you are, um, and see if you can keep figuring out where your perfect squares are and where they are on the number line, so that when you get those irrational numbers or non-perfect squares, you know where they lie between the two whole numbers on the number line. Thank you.